Okay. So if you guys look at this question, it is the same question as we did in the last class. The only difference is that in this question, I'll zoom in, then you guys able to see it. See, there is a little difference in calculation. So they have given you the standard enthalpy change of formation of ammonia. They have given you the standard enthalpy change of formation of water. And what they are asking you to calculate the standard enthalpy change of formation of NO and the enthalpy change of a reaction is given. So as we discussed earlier, if the formations are given, then what we are going to do, we are going to put the elements at the bottom, and if the as the equation contains compounds, so the elements from which those compounds are formed, we are going to put at the bottom. So if you see over here, nitrogen and hydrogen, when reacts, they will form ammonia. But here, how many moles of ammonia are forming?
4 moles.
4 moles. So it means if I'm going to label it, I'm going to label it by 4 times minus 46, right? And this, if when we are doing Hess cycle, we assume it a forward direction reaction, and the enthalpy change is always for the forward direction, which is minus 906. Is this clear?
Yes, sir.
Yes, Kubra?
Can you repeat, sir?
Which one?
Forward reaction हम किस में लेते हैं?
The enthalpy change that they have provided you is always for the forward reaction, not for the backward reaction. So we are assuming one direction in right now. Okay. If we assume it a backward reaction, then the sign would be changed and the value remains same.
Okay, sir.
Okay. Now, from these elements, if I show this arrow, so here two compounds are forming. One is water and one is nitrogen monoxide. And the enthalpy change of water is given, which is minus 242, but here not 1 mole of water is forming, but 6 moles of water is forming. So I'm going to write it 6 times minus 242. Is this clear?
Yeah.
Okay. Now, we have 4 moles of nitrogen dioxide also forming, but that what we have to find, and 4 moles are there, so I'm going to mark it 4x. Is this clear?
Yes, sir.
Yes, Kubra?
Okay.
Okay. Now, can any one of you identify which one is the direct route?
Sir, I had a question.
Yes.
That when the reaction is the reactants of the equation, it's 4NH3 plus 5O2. We're
Yeah.
not adding the oxygen because it's in its element form, right?
Yes.
And that would be the formation would be 0. That's why we're not adding it, right?
Yeah, formation is for a compound, not for element.
Yeah. Okay. So if there was another compound, we would have added that.
Yeah, for sure.
Yeah. Okay, sir.
Okay. Now, which one is the direct route?
The right one.
Right one is the direct route. Yes, very good, because these elements directly converting into NO and H2O, and from the left these are converting into ammonia, and then ammonia on reaction with oxygen converting into these. So this is indirect route and this is direct route. So if I make the expression, it is going to be 4 times minus 46 plus minus 906 is equals to 6 times minus 242 plus 4x. So if I have to calculate the value of x, it is going to be 4 times minus 46 plus, okay, plus minus makes it 906, and minus 6 times minus 242 divided by 4. Now, if you calculate the value of x, it will be the enthalpy change of formation of nitrogen monoxide. Is this understandable how I have attempted this question?
Yes, sir.
Okay, can any one of you tell me the answers, please?
90.5.
Sorry,
90.5.
positive or negative?
Positive.
Positive 90.5 kilojoule per mole. Yes, Amna, is this clear to you as well?
Yes, sir.
Okay, now have a look at this question. This is a little different in a way that they haven't given you the equation and you have to make the equation. So let's see how we will do this one. So if you see here, they are saying calculate the standard enthalpy change of formation of CS2. So I have to calculate the enthalpy change of formation of CS2, right? From the following data. And they haven't given me us equation. So if I'm going to make the equation would be where CS2 is our product and it is forming from its elements. So I have to make the equation like this because this equation represents the standard enthalpy change of formation of CS2. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. Now have a look over here. Standard enthalpy change of combustion of CS2. If you combust CS2, so it means that CS2 is now reactant. When I combust it, what it will form?
Carbon dioxide.
And
Sulfur dioxide.
very good. Carbon dioxide is formed and sulfur dioxide is formed. As there are 2 sulfurs, so 2 moles of sulfur dioxide will form. Is this clear?
Yes.
Ji, sir.
Okay. Now if you see, they have given us its enthalpy change, which is minus 1110, right? Now, if you see here, standard enthalpy change of formation of CO2. So if you look over here, CO2 is here, and here the element is here. So it means that for the formation of CO2, and for the formation of SO2, these two reactions are represented by putting the arrow in a downward direction from the elements towards CO2 and SO2. Is this understandable?
But sir, हमारे पास ऑक्सीजन तो है ही नहीं उस रिएक्शन में, तो how would it form like CO2 and SO2?
So what you can do, you can just put oxygen over here and over here, as CS2 is combusting, forming CO2 and SO2 in the same way. Carbon is combusting with the oxygen and the sulfur is also combusting with the oxygen.
So would it not affect the enthalpy change of combustion of CS2?
Sorry, can you repeat?
Like adding 3 moles of oxygen, would it affect the enthalpy change of combustion of CS2, or would the CS2 remain the same?
It remain the same. If it's a standard enthalpy change of combustion of CO2, what is combustion? The reaction of a substance in excess oxygen, right?
Yes.
So there must be oxygen over here as well.
Oh, right. Yeah, okay, sir. Got it.
So if you don't write in both the sides, it is understandable. Otherwise, you can write it for your understanding. It's up to you. Okay.
Yes, sir.
Kubra, is this clear to you as well?
Yes.
So the arrow which I have drawn from the elements carbon and sulfur towards carbon dioxide and sulfur dioxide is representing the formation of carbon dioxide, and 1 mole of carbon dioxide is being formed. So its value is going to be minus 395, but 2 moles of sulfur dioxide are formed. So I have to add twice of minus 298 because it's twice of the formation of SO2. Is this understandable to all of you?
Yes, sir.
Okay, now see, we made the Hess cycle. Okay, now if you see the arrows, these arrows are exactly opposite to the arrows which I draw in this Hess cycle and which you guys draw in the previous class, isn't it?
Yes, sir.
Okay, now if you see this Hess cycle closely, can you identify which one is the direct route now?
The left one.
The left one, very good, Amna. See, from these elements to carbon dioxide and sulfur dioxide is the direct route, and the indirect route, they first turn into CS2 and then CS2 turns into carbon dioxide and sulfur dioxide. So this is the direct route and this is the indirect route. Is it clear now?
Yes, sir.
Yes, Kubra? Okay, now Amna, did you remember you have asked me why do we can use the formula as well, right?
Yes, sir.
So if you see here, there is a trick. See, one compounds for one compounds they have given you the combustion, and the other compounds you are giving you the formation. So you don't able to identify which formula you are going to use, either product minus reactant or reactant minus product. Are you getting my point?
Yes.
So the best way, it takes a little more time, but the best way is to, make the Hess cycle. If you make the Hess cycle, then, it will provide you the actual picture and you can easily make the mathematical expression to solve it. So now if we see, our mathematical expression will be minus 395 plus 2 times minus 298 is equals to enthalpy change of formation, which we can substitute by x as well, plus minus 1110. So if I make the enthalpy change of formation as a subject, then it will be minus 395 plus twice of minus 298 and then minus 1110. Now if you solve it, you will get the answer. Is this understandable to both of you, Kubra and Amna?
Yes, sir.
Yes.
Okay. Now,
One
calculate.
one nine.
Sorry, yes, Kubra.
119, sir.
Positive 119.
Ji.
Yes, sir.
And do remember to mention the unit as well. Is this clear?
Yes, sir.
So now shall I give
Ji,
you
sir.
guys a question to attempt? Okay. So here you go. Just a minute, please. Okay. Now attempt this one. I have received Kubra's. See, Kubra, you did the mistake. What is this?
Standard enthalpy change of combustion.
Combustion. So the way you made the arrows, you put the elements beneath. Why? If there is a combustion, so on combusting methanol, what you will get?
Water
And
and
Amna, can you show me the working? So see its combustion. And when the combustion is there of, for example, we have a combustion of methanol. So when I combust it, I will get carbon dioxide and 2 moles of water, because there are four hydrogen in CH3OH, isn't it? And this value is unknown, I have to find this. And for this combustion of methanol, the combustion of methanol, enthalpy change of combustion of methanol is minus 726. Okay, so when you combust carbon monoxide, what you will get?
carbon dioxide and water.
Carbon dioxide. For carbon monoxide, you will get carbon dioxide, and when hydrogen is combusted, it's water. Okay, everything is correct, Amna, but the only thing is that why you put the elements beneath? Because it's not formation, so we don't need elements, isn't it?
Yes, sir. Sorry, I forgot that.
Yeah, so we have to keep these things in mind. When the formation is there, then we will put the elements, but when combustion are there, we are going to put the combustion products. So 1 mole of carbon monoxide is combusting, so its enthalpy change is going to be minus 283, and 2 moles of hydrogen is undergoing combustion, so it is twice of minus 286. So now if you see, the left one is our direct rule, so the expression will be minus 283 plus twice of minus 286 is equals to x plus minus 726. So if we make the x subject, your answer is correct, Amna. Kubra, did you understand this?
Ji, sir.
So the value of x is going to be positive 129. No, sorry, negative 129. What was it, Amna?
Sir, negative 129.
Negative 129. Now, is this clear to all of you?
Yes, sir.
Ji, sir.
Okay. Now do this one. Solve this one quickly. Okay, I have received from Amna. Yes, I have received from Kubra as well. Kubra, it is 1411, not 144.
Okay.
So correct your value. Okay. Now do this one. So it's all on practice. How much you practice, it will become easier. Now both of you do this one.
सर इसमें हम लोग नीचे सारे एलिमेंट्स लिखेंगे ना because it's formation.
Yes, because it's formation. Yeah, good. So you have to identify where you have to write the combustion product while making the Hess cycle and where you are going to use the elements. So it's formation, so elements. Good. I have received from Cobra. See how many moles of ammonia are forming in Cobra?
Okay, sir, सही है.
So you have to multiply 81 times 2, isn't it?
जी, मैं सही कह रही हूँ.
So correct the do the correction. Now minus 287 minus 320 plus h. Okay. Yes, yours is correct. Now. So now we did all type of questions from enthalpy changes. So here, if we meet the expression after making the Hess cycle, so the expression would be like this. If I meet the expression minus 414 plus twice of minus 81 is equals to minus 287.0 plus minus 320.5 plus delta H, and then we have to make delta H subject and find its value. Yes, if you guys have any question, you guys can ask, please. Yes, Amna and Cobra.
No, sir, I'm good.
Okay.
Yes, sir, कोई प्रश्न नहीं.
Okay, that's fine. So we are ending this class over here, and in the next class we are going to start with, I think we are going to start redox reactions. Okay.
Okay, sir.
Okay, then take care, everyone. Allah
Allah Hafiz, sir.
Hafiz.